So this problem says 2 moles of a monoatomic ideal gas at 5 megapascals and 5 liters is expanded isothermally until the volume is doubled. Step 1. Okay, so then it's cooled isochorically until the pressure is, what is isochorically? Isobaric and isochoric are the same. Until the pressure is 1 megapascals. The temperature drops in this process. The gas is now compressed isothermally until its volume is back to 5 liters. But its pressure is now 2 megapascals. Step 3. Finally, the gas is heated isochorically to return to the initial state. Step 4. Draw the 4 processes on a PV plane. Find the total work done by the gas. Okay, so let's 2 moles of a mole is expanded isothermically. Okay, so the initial is, this is in megapascals. Megapascals is 1,000,000 pascal. 1 megapascal is 10 atmosphere. Okay, 10 to the power of 5 pascals is 1 atmosphere. So this is 10 atmosphere is the units. So 50 atmospheres and volume is in liters. That's 5. Okay. It's expanded isothermically until its volume doubles. So here's an isothermal expansion. This is step 1. And the volume doubles, so that becomes 10 liters. Then it's cooled isochorically until its pressure is 1 megapascals. Isochoric is, I guess, isobaric. Okay, then it's cooled isochorically until its pressure. Okay. Isochoric is, okay. All right, so then you're going down like that. So this is step 2. And that's 1 megapascals. Okay, so 1 megapascal, 10 liter, and 1 megapascal. So the coordinates of this point are okay. And then what do you do? The next thing you do is the temperature drops in this process. The gas is now compressed isothermally until its volume is back to 5 liters. Okay. All right. So now we're going isothermically back to that point. Okay. So this is step 3. And then finally the gas is heated isochorically to return to the initial state. Okay, so there is step 4. All right, so there is the process on the PV diagram. Okay, so these 2 steps are isotherms and these 2 steps are isovolumetric process. I always think of it isovolumetric, and isochorically throws me off. Okay. So finally, find the total work done by the gas. Okay, so 0? No, the work done is this area. And the work is positive because you're going clockwise. If you're going counterclockwise, the area would be negative. So the work done is just the area under this curve minus the area under this curve. Okay. So I guess what we'll do is we'll call this volume 1, V2, V3, V4. well, I mean, those volumes are given 10 liters and 5 liters. Okay. So in process 1, work done in process 1 is nRT log V2 by V1. Work done in process 3 is negative nRT log, we don't have to put negative, it will take care of final volume is less V4 divided by V3. And this work will come out negative because V4 is smaller than V3, and this will be negative. Okay. So the total work done. So the total work done is V1. Okay. Well, to be more precise, I'll write V1 plus W2 plus W3 plus W4. These two works are 0 because during isochoric processes you do 0 work. Okay. So the total work done those are at different temperatures, so we'll have to find those temperatures. nRT1 log 10 over 5 plus nRT2 log 4 over 3. And this is, you guys understand that, see, this thing, okay, I'll write it in 2 steps. Minus nRT2 log 10 over 5. Everybody understand that? Okay, what we've used the following rule. That's the rule we use. Okay. So this is nR log 2 T1 minus T2. All right, so let's see what all is given. 2 moles, they give us the number of moles. R, the temperature drops in the process. So they don't give us the 2 temperatures, so we have to find T1 and T2. Okay? So, all right, so let's calculate T1. Okay, so they give us, so to calculate T1, we know the volume and pressure at that state, and we know the volume and we know the volume and pressure at this state. Okay, so let me write down the coordinates of this point is 5 megapascals, and the coordinate of this point is 10 and 1 megapascals. Okay. All right, so to calculate T1, we know P1 V1 equal to nRT1. So T1 is P1 V1 over NR, and P1 is 5 megapascals. V1 is 5 liters. N is 2 moles. Okay, and then Newton meter squared times meter cube is a joule, and that will cancel with that, mole cancels with that, and you get a Kelvin on top. Okay, so the temperature T1 is, let's take care of powers of 10, that's 10 plus 3, that's 5,000, divided by 2 into 8.31, oops, 25,000. Correct? Wow. Did I do something wrong? No. Okay, so T1 is 1503 degree Kelvin. Similarly, T2 is, we will use the following point. We'll use this point to calculate T2, the temperature for this isotherm. This point has coordinates 10 liters and 1 megapascal. And this will work out too. (601 degree Kelvin). All right, so now we'll take that and put it in here. So the work done during this cyclic process, okay, again, so all we're doing is calculating the work done in one cycle. That's what we're calculating. Okay. Is NR log 2 and again the moles cancel and the kelvins cancel with that. Okay, so you're left with joules. Okay, so in that one cycle you did 10,400 joules of work. Any questions?